Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important topic, that is from electromagnetic theory core CSIR syllabus. In electromagnetic theory core CSIR syllabus, the first topic is electrostatistics. In electrostatics, we are discussing the Coulomb's law and application of the Coulomb's law. We discussed and we uploaded in our YouTube channel. And so we discussed about the second topic is Gauss law and their applications are there. So from the Gauss law also one question I discussed and uploaded in our YouTube channel. Now today we are discussing about the applications of the Gauss law. How we have to learn about a applications of the Gauss law. This is very important concept. Now you able to see. This question was asked in CSIR December 2012. For 5 marks they are asking this question. How simple you able to see. First you have to read the question 2-3 times. Then you understand what data they are giving in that question. Later you have to segregate and to what we need to find from this question you have to make it, that is 50% of the solution is completed. Later which question, which formula is fitting, how we have to follow the procedure to solve this question, you able to see. One more 50% is completed, the answer will come, correct answer will come, you follow the correct procedure. Now you able to see, consider a hollow charged spherical shell. This is a hollow charged spherical shell. Which one it is? Consider a hollow charged spherical shell you have to consider. Consider a hollow charged spherical shell of inner radius is A and outer radius is B. The volume charge density they are giving, that volume charge density is equal to what data they are giving, that volume charge density data I am writing here. So the volume charge density rho of r is equal to, the volume charge density rho of r is equal to k by r square. This is the volume charge density. In the region, which region it is? A is less than r is less than b. A is less than r is less than b. The magnitude of the electric field produced at the distance r is greater than a also we need to calculate. So in the distance one more you have to take, then we need to calculate the electric field at electric field at A is less than r is less than b. Electric field at so r is greater than a. When r is greater than a, we need to calculate, that is r is greater than not a, that is r is greater than b. You able to take, this is r is greater than b. R is greater than b you have to consider. So that is the r is greater than b. So then you able to find out. So consider a hollow charged spherical shell of inner radius is a and outer radius is b. The volume charge density they are giving, within the region volume charge density is there, that is a is less than r is less than b. The magnitude of electric field produced at a distance r is greater than b is how much? When r is greater than b and r is greater than a, so when r is in between the a and b, how much we need to calculate? How we have to calculate? Once you have to see, first case we have to do the case. What is that case? Once you have to take, our case is A is less than r is less than b. A is less than r is less than b. Already we discussed in the ARP classes how we have to apply the Gauss law. To find the electric field, we have to follow the 4 steps. What are the 4 steps? What is the step number 1 you have to see? First step number 1 you have to follow. What is your step number 1? Find the, construct the Gaussian surface. Step number 1 is construct the Gaussian surface. Construct Gaussian surface. First you have to construct a Gaussian surface. This is the step number 1. We need to construct the Gaussian surface. Based on our case, we have to construct the Gaussian surface. Suppose you have to see it is a spherical shell. What is that radius? A radius is there. This is a point O. Now one more spherical shell you have to take. So that radius is equal to, how much radius is there? That radius is B radius is there. This is the another, so outer radius is there. So now this one is a hollow spherical shell that we have to take it as a hollow spherical shell. The charge density is present here only. Now you have to construct the Gaussian surface. That Gaussian surface you have to construct. Where you have to construct the Gaussian surface? In between the A and B you have to construct. In between the A and B I am constructing the Gaussian surface. That distance is equal to R distance at particular area. So you have to take it as a ds area. So that in the Gaussian surface the electric field is always normal to the Gaussian surface. So therefore you need to take the angle between whom? Angle between E and ds is equal to 0. E and ds is equal to 0 means theta is equal to 0 degrees. So if it is theta is equal to 0, cos 0 is equal to 1. This is the step 1. Now you able to do the step 2. What is your step 2? Find the electric flux. Your step 2 is you need to find the electric flux. How we have to calculate the electric flux of a Gaussian surface? What is the formula? Phi A is equal to integral EDS cos theta. So therefore phi A is equal to, you have to take the E outside because at all the points on the Gaussian surface that electric field is same. So therefore that is uniform electric field. That's why you have to take outside. Cos theta is equal to 1 and integral ds is there. So what is the area of the sphere of the Gaussian surface? So that is area is equal to, area of the sphere is equal to 4 pi r square. This is the flux of a Gaussian surface. Once we need to calculate the flux, now we have to follow the step 3. What is your step 3? You calculate the charge enclosed through a Gaussian surface. Charge enclosed through the Gaussian surface. The charge enclosed through a Gaussian surface is equal to, what is your charge? It is a rho dV, volume charge density I have to take. But our rho dV is not according to the diagram. You have to take it as, we are splitting this integral from 0 to A into rho dV plus from A to R into rho dV. We are splitting the integration. From 0 to A there is no charge density because it is a shell. So that's why inside the inner radius sphere, so there is no charge density. That's why you have to take it as a 0. So therefore what we have to write, in A to R, rho is equal to, they are giving that value is equal to k by r square into dV. K by r square into dV. So therefore we have to write charge enclosed through a Gaussian surface is equal to integral A to R k by r square, but that volume is equal to, what we have to write, that volume element of a sphere is equal to 4 pi r square into dr. This is the volume element of the sphere. So what is that volume element of the sphere? dV is equal to 4 pi r square into dr. So now you have to take the r square get cancelled. 4 pi k you have to take outside because that are the constant. Integral dr is equal to r. You apply the upper limit and lower limit, you able to get 4 pi k into, so which one we are getting? R minus A we have to get. This is the charge enclosed through a Gaussian surface. Clear? charge enclosed through the Gaussian surface is equal to 4 pi k into r minus a. Now we need to follow the step 4. So what is your step 4? Your step 4 is equal to apply the Gauss law. What is your Gauss law? So your Gauss law is equal to the electric flux phi is equal to charge enclosed through a Gaussian surface is divided by epsilon naught. What is your electric flux? Your electric flux is equal to E into 4 pi r square, correct, which is equal to charge enclosed through a Gaussian surface is 4 pi k into r minus a is divided by epsilon naught. What are the things are there? 4 1 ja, 4 1 ja, 5 1 ja, 5 1 ja get cancelled. Therefore, that electric field when A is less than or is less than B is equal to K into is divided by epsilon naught into R minus A is divided by R square. This is the electric field at case number. So, A is less than or is less than B. Now, not finished. Now, we need to take some more is there, that is the case number 2. What is your case number 2? When R is greater than B. When R is greater than B, how we have to calculate the electric field? That is also very important. When R is greater than B, we have to follow the 4 steps. Here also we have to follow the 4 steps. What is the step 1? Step 1 is construct the Gaussian surface. Construct the Gaussian surface based on your case. Construct the Gaussian surface. We are constructing the Gaussian surface based on your case. So, what is your actual sphere is there? Spherical shell is there. This is the inner radius A. There is a outer radius. You have to take it as a B. Now, we need to construct the Gaussian surface. This Gaussian surface is so greater than the radius of outer radius B. So, this is the R you have to take. Now, the area you consider as a ds area. That electric field is always normal to the Gaussian surface. So, therefore, that angle between whom and whom? The angle between E and ds. The angle between E and ds is equal to 0 degrees. So, therefore, theta is equal to 0 degrees. Cos 0 is equal to 1 we have to write. Now, next step 2. What is your step 2? Your step 2 is similar procedure you have to find out. Find the electric flux through a Gaussian surface. Find the electric flux phi E is equal to integral E ds cos theta. E ds cos theta is there. So, wherever you go, at all the points on the Gaussian surface, the electric field is the same. That is why you have to take outside integral ds cos theta is equal to 1, that is the cos 0 is equal to 1. Therefore, integral ds is equal to 4 pi r square we are getting, which is equal to, that is the electric flux is equal to. Now, you able to see what is that one? That is a step 3. What is your step 3? Your step 3 is we need to calculate charge enclosed through a Gaussian surface. Charge enclosed through the Gaussian surface is equal to integral rho dV. But we need to say how we have to write this rho dV. First you have to take 0 to a inner radius you have to find out, that is rho dV. Next you are able to calculate so a to b you have to take a to b into rho dV. Next you have to take one more, you are splitting the integrations. So, b to r into rho dV you have to write it. So, this is a shell, but innerly there is no charge distribution, rho is equal to 0. So, but in outer also there is no charge distribution, rho is equal to 0. Where it is existing, we are existing only the charges existing between the A and B. So, that is why you have to take it as a integral A to B. So, rho dV you have to write it. Now, you able to take how we have to write that. So, now you substituted charge enclosed through a Gaussian surface is equal to integral a to b rho dv, but rho is equal to, we know, integral a to b rho is equal to k by r square, but dv, what is the volume element of the sphere, is equal to 4 pi r square into dr. So now you able to take the constants outside, 4 pi k integral a to b r square get cancelled, integral dr. So integral dr is equal to r, you write it is 4 pi k into b minus a. This is which one it is? Charge enclosed through a Gaussian surface. Charge enclosed through the Gaussian surface is equal to 4 pi k into b minus a. Now we need to apply the step 4. So what is your step 4? Apply the Gauss law. What is your Gauss law? Phi e is equal to charge enclosed through a Gaussian surface. Charge enclosed through the Gaussian surface is divided by epsilon naught. What is your phi e? Your phi e is equal to E into 4 pi r square, which is equal to charge enclosed through the Gaussian surface is equal to 4 pi k into b minus a is divided by epsilon naught is there. So therefore 4 1 ja, 4 1 ja, 5 1 ja, 5 1 ja get cancelled. E outside when r is greater than b is equal to how much we are getting? K by epsilon naught into b minus a is divided by r square is there. This is the electric field when outside the, so when outside the outer radius of the spherical shell. Clear? Now you able to see the answer, because it is a 5 marks question we need to solve. So you have to see when r is greater than, you able to get it is not correct. So in between b minus a is not correct. So when a is less than or is less than b, so k by epsilon naught into r minus a epsilon naught a square is correct. Now you have to see when r is greater than b, k by epsilon naught into b minus a r square, this is also correct. Which option is correct? Your option C is correct. So how many marks you able to get? 5 marks you are getting in your competitive examination. How simple is there? Just simply you have to apply the Gauss law, you will get the 5 marks question. Once again I am informing to you, so we started the CSIR and GATE online mode, app mode coaching. So that is, you know that already we started. So we finished 2 papers, those papers now available as the recorded mode. Now we are under the electromagnetic theory. So the electromagnetic theory live plus recorded classes are going on, right? Every day morning 6 a.m. to 8 a.m. In between the 6 a.m. and 8 a.m. there is a class from the electromagnetic theory in our app, not in YouTube, in our app, to canvas, to estimate my teaching style and my teaching caliber. So that's why I am teaching in the YouTube, not free in the YouTube, right? So that app you have to purchase it. If you really likes my teaching, you go to your Android mobile phone, download my app, that is Quantum Online Academy app. Once you have to download my app, you be able to see the courses. So if you have any doubt, you contact with me. My number is 9908437460. So this course will appear like this: CSIR and GATE physics, and JL physics and DL physics also will be available. CSIR and GATE mathematical methods of physics. So this course is available, and CSIR and GATE classical mechanics course also available. And so now this course is live course is going on. Individual paper also, if you want, you have to take the individual paper also. Please share and like and subscribe our YouTube channel. Your subscriptions and your likes and your comments encouraged me to teach in the YouTube also. Thank you so much.